Dear students, in last classes we have started the topic of transistors. The transistors are, in fact, the word transistor is the combination of transfer plus resistance. So transfer of resistance, collectively it is known as the transistor. We have gone through the basics of the transistor, and we have gone through the fundamental component of the electronic devices known as the diodes, and we have thoroughly discussed that how the semiconductor materials are behaving and how we can make the semiconductors as useful by using the doping process. The doping process is in fact to add the impurities in the material. We also gone through the PN junctions. P stands for positive and N stands for negative, or in other words, the P indicates to the majority of holes and N indicates to the majority of electrons. Just to recall your memory, we also discussed that how the forward biasing and reverse biasing work, how they exhibit the behavior while we are providing some potential difference to the PN junctions. In nutshell, we also discussed the depletion layer that is produced naturally while we are combining N-type material with the P-type material. So that is in fact the fundamental concept of the semiconductors that also reflects or that also helps to understand the transistors. Transistor is in fact working on the principles of that PN junctions. Some modifications are to be made into these PN junctions and we can get the transistors. Referring to the book of Louis Nechlesky, it is said that when we were discussing about the diodes, so di indicates to the two polarities, those were the P and N. Here we can say that a transistor is a triode, means it is having three polarities, and two same polarities are separated with the different polarity. Just to make it easier, so we can say that two N junctions are separated by P layer, or two P layers are separated by the N layer. So we can say that PNP type of transistors or NPN type of the transistor. So there are different types of the transistors, but at the moment we intend to understand the basic type of the transistor known as the BJT, bipolar junction transistors. So as I told you that The transistor is a combination of two words known as transfer plus resistor. So collectively it is known as the transistor. The students, you should note it down that we can say in other words that the transfer of current from a lower resistance part to a high resistance part is the function of a transistor. I repeat again that the transfer of current from a lower resistance part to a high resistance part is the basic function of a transistor. This is the basic understanding block diagram that how can we construct a transistor, that the transistor, the layers, the P layer and this P layer is separated by N layer. So it is known as the PNP type of the transistor, right? So the vice versa may be there, that NPN. So it does not make any difference, but the concepts will be the identical, but symbols and the different components will be in revert mode. How I would explain. So what happens that it is having now three different polarities or the terminals, as it is apparently can be seen that one terminal is this one, the second terminal is this one, and the third terminal is this one. So there are two loops, in fact. This loop, this complete loop is there, and this complete loop is there. E indicates to the ammeter. E indicates to the ammeter terminal. B indicates to the base terminal, and the C indicates to the collector terminal. The second major concept that I would like to make it clear here, that this ammeter part, this is highly doped. The doping density is very much high in this part, in this P type of material. Means we are adding more impurities. For example, we are adding the pentavalent material to create more charge carriers, so the majority carriers become the holes. So it is highly doped. High density doping is here in the ammeter part. Then we are having the base part, that is the N part, and this figure indicates that it is very thin. Normally it is in the micrometers. This part is very thin, so we can say that it is very lightly doped. It means the impurity materials, addition of the impurity materials is relatively very low. This layer is also very thin. You can compare this value with this value. So it is apparently, and it is self-explanatory, that this layer is very thin. The third layer, that is on the right side, that is the collector side, and this P junction, in fact, this is moderately doped. Obviously it will be relatively low doped as compared to the emitter, right? So it is moderately doped. Okay, so in this way this transistor is constructed. Now the names in fact indicate according to their functions. As the name emitter means emitting something. When we are providing some potential difference to this terminal, one thing is that it is what it is known as the input part. It emits the charge carriers to and passes the charge carriers to the next layer, in fact, when the potential difference is applied. When the battery power is applied to this emitter terminal, it helps to pass the charge carriers to the next junction or portion or region. Why? Because it can easily be seen through this figure that the positive terminal is connected with the P type, means positive, and if you recall your memory, it makes this portion as the forward biasing. Got it? So this portion, emitter portion, it is connected in such a way that forward biasing takes place. While on the other hand, we are having this collector side is connected with the negative terminal of the battery. So what happens? The positive, means P type, is connected with the negative terminal of the battery. So how would it behave? Obviously in reverse biasing. So we can say, as indicated in this text, that this is also known as the forward and reverse biasing. Forward reverse biasing. Forward reverse biasing. And this is indicated in this way here in the text: forward reverse forward bias diode, or forward reverse biased transistor, it is known as. So what happens? This works in the forward biasing mode, and this behaves in the reverse bias mode. As I told you in starting, a definition that transfer of current from a low resistance part to a high resistance part. So it is obviously, and it is very much clear now, that this works in the forward biasing, means it is having the low resistance. It behaves, or it works in the reverse biasing, it means it is having the high resistance. So the current flow from the low resistance part to the high resistance part, it justifies that definition. So what will happen when the potential difference will be provided to the ammeter, and when it crosses the threshold value of the semiconductor material, as for the silicon or the germanium, for example, 0.7 or 0.3 values, when it crosses that threshold value, the current flow will be rising abruptly. Similarly, when we are providing the potential difference in the reverse biasing, almost no current will be produced, and the current line will be on the horizontal x-axis line, as the graph we have studied in diodes. Another thing that should be kept in mind, that this input part, low resistance input part, in fact the battery is connected with the ammeter terminal. So the potential difference or the voltage is denoted by VEE. This VEE indicates that the potential difference or the battery is connected with the ammeter terminal. While the second terminal, that is the collector, is connected with the battery. So that VCC, that potential difference is denoted by VCC. Here in both voltages, the B or the base does not exist, because it is having no importance in this type of the circuit. So VEE and VCC, these matter. Another point is to be noted, we are having the circle. This is a symbol of a transistor. At this moment we don't know whether it is PNP type of the transistor or NPN type of the transistor. Another basic point that should be kept in the mind, that the base is identified by its symbol with the base line. The confusion may be there with the ammeter and the collector terminals. One is the collector and second is the ammeter. So how we can distinguish this ammeter and collector terminals? So the answer is by putting an arrow in the terminal, in the ammeter terminal, while C remains normal without arrow. Remember, the confusion may be there with the collector and ammeter terminals that which one is the collector and which one is the emitter. To distinguish them, an arrow is to be put on the emitter side and collector terminal remains normal without an arrow. Again, another question arises here, that how can we know that is this PNP type or the NPN type of the transistor? So remember that the arrow direction must be from positive to negative terminal. I am talking about the emitter. So remember, the arrow direction indicates what type of transistor is this, either NPN or PNP. And this arrow direction must be from positive to the negative terminal. How? For example, this arrow direction is from emitter to base, as indicated over here. This arrow direction is from emitter to base terminal, and according to the definition, it is from positive to negative. It means it is P type, it is N type, again it is P type. According to the definition, the arrow is from positive to negative terminal. It means it is P type, it is N type, and it is P type again. Once again, for example, it is NPN, NPN. We can also see this figure that I have drawn here, that this is N type, this is N type, this is P type. So how can we know that what is the type of this terminal, this type of transistor? So in this case, we know that an arrow must be put to the emitter terminal. So whether from towards outward to the emitter or inward to the base. So it shows the direction of the arrow must be from positive to negative. So the arrow